Hey there, and welcome. We're about to jump into something that's, absolutely fundamental for any Python developer, getting a real handle on Python's built-in data structures. Honestly, getting this right is the secret to writing code that's not just clean, but also super efficient and powerful. All right, so picture this. Every single project you start, it all begins with this one question. You've got user info, maybe some sensor readings, or a bunch of financial data. Whatever it is, the choice you make right at the beginning, how you decide to contain that data, is going to have a huge impact on your program's speed, its memory usage, and even how easy it is to read later on. So how should we think about this? Well, I find it helps to imagine a programmer's toolbox. I mean, you wouldn't use a sledgehammer to hang a little picture frame, would you? Of course not. The same exact logic applies here. Lists, tuples, dictionaries, these are your tools. And our goal today is to figure out which tool to grab for which job. So, here's the game plan. We'll kick things off with containers for fixed data. Then we'll jump into structures built for super fast lookups. After that, we'll get into the flexible stuff like lists and sets. See how to manage the order you process things? And then finally, we'll tie it all together so you can always pick the right tool for the job. All right, first up, let's tackle those times when your data has a really specific, known structure. Think of coordinates on a map, like an X and a Y value, or an RGB color code. The data is basically a single record, and the last thing you want is for it to change by accident. And for that job, the main tool you're going to reach for is the tuple. Now the key word here, the one you have to remember, is immutable. Once you make a tuple, that's it. It's locked in. You can't add things, you can't remove things, you can't change things. And that's not a limitation, it's a feature. It's all about guaranteeing your data stays put. And this right here, this is the classic showdown, the unchangeable, lockdown tuple versus the flexible, changeable list. A list is great when things need to change, like a to-do list where you're always adding and removing items. But a tuple's immutability makes it faster and way more memory efficient. So the key takeaway is, if your data represents a single fixed record, a tuple is almost always the better call. Okay, so when exactly do you grab a tuple from your toolbox? Well, when you've got a fixed record and the order of the items is important, like X, Y coordinates. And here's a super important one. Because they can't change, tuples can be used as keys in a dictionary, something a list could never do. And we're going to see exactly why that is in just a minute. But, accessing data with 0.0 and 0.1 isn't exactly readable, is it? What if you want something more descriptive? Well, Python's got you covered with the named tuple. This thing gives you the absolute best of both worlds. You get the speed and safety of a tuple, but with nice readable attributes like point.x and point.y. Okay, but what if you love that structure, that organization, but you really need to be able to change the values? Since Python 3.7, the data class is your best friend. It lets you create what is essentially a regular class, perfect for grouping data together, but without writing all that boring boilerplate code. It's a real game changer. All right, let's totally switch gears now. What if your main goal isn't just to store data, but to get it back out again, incredibly quickly? For this, we need the undisputed champion of fast lookups, the dictionary. It's Python's ultimate tool for mapping keys to values. So, what's the secret sauce that makes dictionaries so blazingly fast? It all comes down to this one idea, being hashable. Basically, any object that can't be changed can be instantly converted into a unique number, its hash. Dictionaries use that hash to go directly to the value's location in memory. It's like having a perfect magical index for all your data. And this is where the rubber meets the road. Look at what's hashable and what's not. Strings, numbers, and, you guessed it, tuples, are all hashable because they are immutable. They can't change. But a list, it can change. If you used it as a key, its hash value could change and the whole dictionary lookup system would just completely fall apart. And that's exactly why you can't use mutable types as dictionary keys. Dictionaries are so awesome that Python has built specialized versions of them. Here's a pro tip. If you ever find yourself needing to count how many times each item appears in a list, don't write a for loop from scratch. Use collections.counter. It's basically a dictionary under the hood that's been hyper-optimized for exactly that task. Okay, let's move on to the real workhorses of Python. The tools you're probably going to use all the time, lists and sets. These are your go-to containers for collections of items, but they're built for two very different jobs. So here's something we've all written 1,000 times, right? The classic for loop to build a list. You make an empty list, You loop over your items, and you append the result. It's clear, it totally works, but it's not always the best or most Pythonic way to do it. But now, look at this. This is what we call the Pythonic way, a list comprehension. It takes all that logic from the for loop and packs it into one clean, super readable line. It makes the exact same list, but it's more concise and it's often faster because all the looping is happening in highly optimized C code behind the scenes. So what's the fundamental difference between a list and a set? It really boils down to two things: order and uniqueness. A list keeps your items in the order you added them, and it's totally cool with duplicates. A set, however, is unordered, and more importantly, it will only store unique elements. This also means if you need to check if an item is in a huge collection, a set is way, way faster than a list. Sometimes it's not just about what you store, but when you process it. The order of operations can be absolutely critical. And this is where we get into the ideas of stacks and queues, which, it turns out, we can build with the tools we already know. First up, we have the stack. Think last in, first out, or LIFO. The perfect analogy is a stack of dinner plates. You add a new plate to the top, and when you need one, you take one from the top. In Python, a plain old list does this perfectly. You use append to push an item onto the top of the stack, and pop to take that most recent item right back off. And on the flip side, you have the queue. This is first in, first out, or FIFO. Just like a line at a coffee shop, the first person to get in line is the first one to get coffee. Now, you could use a list for this, but removing from the beginning of a big list is actually really slow. The professionals tool here is collections.dq, which is built to be lightning fast at adding and removing from both ends. Whew! Okay, we have covered a ton of ground here. We've looked at tools for data that's fixed, tools for fast lookups, tools for flexible collections, and even ways to manage processing order. So now, let's pull it all together into a simple, practical guide. Okay, this is it. This is the slide you're going to want to screenshot or bookmark. It's your quick and dirty cheat sheet. Need an ordered collection that can change? That's a list. Need a fixed, unchangeable record? Tuple. Need crazy fast lookups? By a key? Dict all day. And for just storing unique things and checking for them quickly? You want a set. It's all about matching the tool to the problem you're trying to solve.
And that's a wrap. You're now armed with the essential tools from Python's Data Toolbox. So the next time you kick off a new project and you've got some data to manage, just pause for a second. Ask yourself, does this data need to change? Does the order matter? Do I need fast lookups? Answering those questions will lead you straight to the perfect tool for the job, every time.